Okay. So, hi everyone. It's always a pleasure to be here. This is my 5th time here or so. I really like coming here. And today, I'm really excited because the keynote kind of like presets my talk. So I'm really happy that Jordi was talking about Kubernetes at the keynote, and now I'm talking about like the opposite. I was really pushing forward to doing like a Back to the Future kind of presentation, but at the end I kind of like went back and did a regular presentation. But like with Jordi proceeding with Kubernetes, this is going to be a really interesting talk about what is happening in the other side of the house, right? So kind of like building some context. A month ago already, there was the biggest cloud conference, kind of like similar to what we are going to have next week at Hamburg, the ISC conference. There was the Cloud Native conference, and there we had the opposite of what Jordi did today, and is that the Cloud Native Computer Foundation presented SLURM as something that they are looking forward. So now we are here in the HPC community talking about Kubernetes, and in the Cloud Native Computing Conference, they're talking about SLURM. So what is happening here? Like, I kind of want to talk about this, like why we are talking about SLURM there, and here we are talking about Kubernetes. Like something is happening between these two communities that we are finally like bridging the gap on like SLURM is good, Kubernetes is good, and let's stop like trash talking, like that's better, this is better, and like we need to build on top of both things, right? So I kind of like wanted to bring this image to everyone that was not there or had, all of these videos are already free in YouTube. If you want to see all the Cloud Native KubeCon Europe, they are already free in YouTube. So what is being kind of like mentioned at the Cloud Native Computing Foundation and the cloud ecosystem? Last year, around November-ish, a company called CoreWeave announced that they will open source a project that was SLURM and Kubernetes. That has not happened, and I think it's not going to happen. But the idea is that they are proposing a SONC, what will become a kind of like a proprietary product from them, and it's how to run SLURM on. So you need to read this on top of Kubernetes. So it's not an idea like Jordi was talking today on having Kubernetes and SLURM co-living together in the infrastructure. This is more Kubernetes deploying SLURM as parts of a Kubernetes cluster, so you can leverage Kubernetes features, right? So what they are trying to look for in this type of architecture is that you can auto-scale using Kubernetes native primitives, right? Like, you know, Kubernetes has native APIs to communicate with all the cloud providers, Google, Azure, Amazon, DigitalOcean, blah, blah, blah. So if you can leverage the native APIs of Kubernetes, you can like quote unquote auto-scale your SLURM cluster using Kubernetes. You can also inject all the Kubernetes native objects into a SLURM. But all of this comes with a caveat. All of this comes with a compromise. And is that for running a SLURM as parts of your Kubernetes cluster, you need to do the -- privilege that we all in the HPC community don't like so much, right? So like why in the cloud ecosystem running ultra privileged SLURM sounds kind of like okay to do is because they are really working towards time to results, and they manage multi-tenancy by creating a cluster for each user, right? Like they really don't care about one cluster for 10,000 students in a university as we care in the HPC community. For them, multi-tenancy is one cluster per user, right? Like in a company that is like totally cloud native, the way they do isolation, multi-tenancy is that each individual has credentials to AWS, to Google, and each individual creates its own VMs, its own instances in the cloud. So like there is no need for like, oh, we are sharing the same cluster, so let's try to have some policies, some security policies. No, they just run each one in their own VM, so they don't care about this architecture that at the end of the day doesn't work when you are sharing a cluster, right? So when we are talking about HPC, and you present this idea where pods will be running because it's not even privileged, it's like ultra privileged, because if not, the SLURM daemon is not going to run as native as we really wanted to do all the things that we want from a SLURM. So that's what this idea is proposing. And they said it was going to be released once winter was done, and now we are walking into summer. So now we as a community are saying like, okay, it was not open source, so we need to take some action on like, okay, how do we bring SLURM and Kubernetes together? And the nice thing is that even from HPC now, there are ideas coming on like, okay, this is how we can bring SLURM and Kubernetes to work together. But I think I just wanted to like set the stage on that. For those that don't know me, my name is a really long name. You can just call me Eduardo. I've been doing these containers and HPC things since Singularity, almost 8 to 10 years ago now. And then move it all the way up to Kubernetes by helping OpenShift get into the HPC space. And now I'm working for NVIDIA, helping everyone leverage accelerators, even DPUs, and network links, right? Like NVLink and InfiniBand. As you all know, NVIDIA acquired Mellanox a couple of years ago. So I'm working to enable all of these hardware tools in Kubernetes and cloud native ecosystem, which means I have to work from the container stack up to enable containers to use this, and then Kubernetes to use this as well. So that's the context of who am I. So I want to first talk about what is the AI lifecycle and where does the cloud native ecosystem plays, and where SLURM is also playing along. So what is the AI lifecycle, right? For those that, for all of us in the HPC ecosystem that are not directly helping AI customers. So this is what usually is the AI cycle, right? Like problem definition, data acquisition. These two are not really computational problems. These are actually like sitting down in a table with a paper, a group of people, and defining the problem, defining where are we going to get the data, which data is going to be used or not. And then the rest of the points are computational points, right? Model development and training, this is kind of like the pre-training phase where the scientists start testing and trying out with a small set of data to kind of like test the hypothesis before launching a big deployment. The model evaluation and refinement, and is that once the big model is trained, you have to run it and test it before actually presenting it to customers, because you can have what is now called hallucination, as we are all calling for ChatGPT, and then deploying and serving it, and maintenance, right? Like these two last topics are very important, because it's like, okay, my model is here, it works, I can do some machine learning, but now how do I present it to my customers, and how do I present it to my customers in a running basis, right? Like I can go to sleep and my customers can still consume this AI model, right? So where does Kubernetes plays along here? It plays along in the entire cycle, besides the 2 points that you need to sit down with a paper and do everything, right? So Kubernetes helps you from development of the model, because there are a lot of frameworks and tooling, as I'm going to be showing next, tools to training the model and even serving the model, and what is now being called ML Ops, right? We started maybe 8 years ago with DevOps, then it moves to GitOps, now is ML Ops. At the end of the day, it's something with the word ops at the end. It means that someone has to be a system admin, and that's like be updating the LinkedIn resume to say that he's now a system admin, now a DevOps, now a GitOps, now a MLOps. At the end of the day, a system admin, right? So MLOps is very important for many of us, because it's like, okay, I did this very complex thing, now how do I support it over time? And for that, Kubernetes is really awesome, right? Like Kubernetes is basically a way to say like, this is how I want the system to be forever, you go do it, right? So Kubernetes is like the perfect tool for that scenario. So first, model pre-training. So for model pre-training, Kubernetes is kind of like beating all the other frameworks, as SLURM and many others, mostly because the frameworks that are being built on top of Kubernetes, right? Like there is this Kubeflow project, there is the MLflow project, and then if at the end I'm going to show the landscape of AI tools for Kubernetes, and it doesn't really fit a slide. That's how big things are getting. Versus in SLURM and other HPC systems, you have to be a very, very advanced user of SLURM, of PBS, of all of these other scheduler tools to actually get some work done, right? So in the pre-training phase, where you're actually just like testing the idea, testing if the data that you have actually will fit the model that you want to have at the end of the day, you don't want to be dealing with the underlying infrastructure like with a SLURM or PBS. And Kubernetes, with its frameworks, it's really helping users get time to results, right? Like users can develop and train a model in a couple of weeks, and then they can start worrying about, okay, how do I do a big deployment? And in this big deployment is where model training, that's where SLURM and AI training comes into place, right? So SLURM, as we all know it, is the perfect tool, right? Like it's the most popular resource manager and HPC scheduler out there. As Jordi showed, it's more like 60-70% of usage. So it's still like the to-go implementation for scheduling. It integrates well with common HPC frameworks, right? Like this is where things start getting like in the caveats. It integrates with HPC frameworks, but there are no PyTorch or Kubeflows or TensorFlow being built for SLURM, right? Everyone is kind of like building on top of cloud-native tooling. So SLURM is used for big HPC type of deployments, and there are a lot of users resourcing to SLURM to train AI models, but for doing so, they require also highly trained personnel, right? And it's not like you can find data scientists that also know SLURM around the corner. So it's really hard, right? Like finding a data scientist that also can write a very nice SLURM job file is not so common. And it's complex to use and complex to maintain versus Kubernetes, because SLURM doesn't manage itself. It requires an active system admin on top of it to manage it, versus Kubernetes that now has also a lot of frameworks and has managed services and has a lot of components that has auto-healing, auto-scaling, auto-everything, right? Like that's kind of like the concept of cloud native. Being able to define a contract, like this is how I want you to be forever. You pass that contract to the platform, and the platform just reconciles over that contract over and over, and it stays the same forever. Versus SLURM, it doesn't have that. You have to write your own plugins, your own scripts to support SLURM over time. SLURM has its gaps, right? The integration with the AI community is not so clear. If you want to build nice things on top of SLURM, you got to build your own plugins, and there is no a big community around it, right? Like versus when you go to cloud native, there is a big community that is being built, and it has big partners behind it, like Google and all these cloud providers, NVIDIA, AMD, Intel. Like everyone is supporting the cloud native tooling ecosystem. Versus in SLURM, if you want to do cool things, you need to become an expert, and then you need to build your own plugins. It was not built for serving. So as I was saying at the beginning on the AI cycle, the last bit is that once the model is trained, once everything is ready, you need to present that to a customer. And for that, Kubernetes is kind of like the shining tool, right? Like Kubernetes, 10 years ago, it was designed for web pages. That was it, right? Like it was designed for that. Once you have something that works, how do I present it to customers and it runs forever? SLURM was not built for serving. SLURM is not built for running a web service. And at the end of the day, once you have a model trained and you just want to do inferencing of that model, it becomes a web service, right? So SLURM was not built for this. Kubernetes was built for this. Learning SLURM can be challenging. Once you're a data scientist, maybe you're doing like your master's degree, your PhD degree, as someone was claiming on when people go and read papers, like 80% of papers about machine learning today are like, I did this on top of Kubernetes, right? So students, not even call them customers, students are reading papers day in, day out, and more than half of the papers mention Kubernetes in some way. So they are becoming Kubernetes users, not SLURM users. So then if you want to be good at SLURM, you have to like purposely train yourself in SLURM. And this is kind of like becoming a less skill than using Kubernetes. And also first point that I want to touch is the static allocation of SLURM is not compatible with data science, right? When you deploy a job in Kubernetes versus deploying a job, or not deploying, like launching a job in SLURM, is more easy to move around the job in Kubernetes than to move around the job in SLURM, right? So Kubernetes was built to like, okay, I can kill this node, move this job here, everything continues, versus in SLURM, you need to be good at SLURM to know how to preempt the job, to know to how maybe pause the job, move it around. So it was not built for that. So the static allocation of SLURM makes it not compatible with how the AI, ML tooling is being built on, right? Like all of these frameworks for AI, ML, they are calling themselves pipelines, right? So the pipeline means that you need to have something after something after something, and even pausing and restarting. And Kubernetes is just much better for that than SLURM. So now introducing Kubernetes. So Kubernetes, but I want to focus on the kube scheduler, right? So Kubernetes, as some had maybe read in some blog posts, it is called KAS, and the 8 means that it is 8 components, and the component that we can compare directly with SLURM is the scheduler itself. Kubernetes has API server and other components that really don't compare to SLURM. Kubernetes has a kube scheduler that really compares not one-on-one with SLURM, but it's like the closest component of Kubernetes that can be sit down together with SLURM. It's flexible for containerized workloads, where this then becomes a caveat, because in SLURM, you can run things without containers, and that's a good thing for some things, right? Like when you want to do a big AI training with PMIX. Doing that in Kubernetes is still not possible. But in Kubernetes, you can use the MPI operator and run regular MPI, but not PMIX. So there are like good comparisons to that. It requires plugins on top of it to get some things done for AI/ML, like Q that Jordi also presented. It doesn't come by default with Kubernetes. You have to deploy it, you have to configure. So it's like, it's not a day 0 operation. It's a day 1 operation. You need to have your Kubernetes cluster running, well configured, before jumping into installing the things that get you to get work done, right? Not like a SLURM, that once a SLURM is running, you can deploy jobs into a SLURM. So that's kind of like the difference with Kubernetes. Is the core of the cloud native ecosystem. Everything that is being built for cloud native, and they call it cloud native, actually just is like, I can deploy this on top of Kubernetes in some way of shape or form, right? So that's Kubernetes for the AI ecosystem. But what do Kubernetes still misses, right? Like there are some things, as I'm saying, like PMIX, that you can still not do in Kubernetes. And the first one that every time I go to a meeting, every time I sit down to talk with people about like, okay, let's do training and big things in Kubernetes, they say like, oh, Kubernetes doesn't have gang scheduling. You cannot do gang scheduling in Kubernetes. Well, it happens that we are working towards that as a community. That recently we approved an API that is called the Leader Workset API, and basically allows you to define groups of pod as a unit. And you can define a leader and a worker as groups, right? So you can say like, this is going to be the leader, and I want a group of workers of N number of workers, and then deploy that. Then behind that, there is a controller making sure that the leader and the worker all start in parallel. That way we can better support MPI in Kubernetes. This was not possible before approving the Leader Workset API. It supports parallel creation, unique pod identity. So if you request N pods, each pod is going to have a unique name, -0, -1, -2, like it's going to be numbered. That way you can, if you requested N MPI workers, you're going to have them named in a unique way. It supports multiple groups. So not just like I want to run one big MPI deployment in my entire cluster, but these AI ML frameworks sometimes require 2 type of distributed works to be running at the same time. So you can deploy a group of 5 and a group of 5 in a cluster of 10, right? Like as an example. So it supports multiple groups, and all of them are going to be started at the same time in parallel. It's a scalable sub-resource. So you can, so the leader workset API works natively with the Kubernetes auto-scaling API, meaning it can do cloud bursting for you. It is topology aware. Coming for the next Kubernetes releases, we are working on topology aware APIs in Kubernetes. For now, it's just topology at the node level, but we're working in topology at the cluster level. So this API allows you to say like, okay, I want group 1 of 5 to be placed in nodes that have this type of CPU, this type of NUMA node, this type of GPUs. That way you can make use of the Kubernetes scheduler and the leader worksite API to make sure that your pods are going to be running next to each other, or at least on machines of your interest, right? And it has the all or nothing restart or failure, right? So all of them need to start at the same time, or Kubernetes is going to kill them and start again to make sure that all of them start at the same time. And this way preventing what the NPI operator was kind of like struggling with years ago when trying to run NPI in Kubernetes, that sometimes if you have a cluster very big, like 100 nodes plus cluster, sometimes Kubernetes will spin up 50 nodes and then the other 50. And for NPI, this was kind of like not good because 50 nodes were already up and 50 nodes were like getting up, and the NPI operator will launch the job for 100 ranks, but only 50 ranks were available. Now with the leader worksite API, Kubernetes is going to make sure that the 100 nodes are ready before launching the job. So this is good. So this kind of like solve GAN scheduling for Kubernetes. Yes, it's 95% of the use cases. We still don't support all of the use cases. And as I said at the beginning, PMIX is still not supported, but we now have a native way of supporting GAN scheduling in Kubernetes. Another thing, batch scheduling, right? As I was saying before, and as Jordi presented, you need to install tools on top of Kubernetes to get it to do batch. Because Kubernetes is basically, every time you request something, it is going to deploy it, and no matter what. Right? Like Kubernetes was designed for oversubscribing resources. So now we have Q. The Q project is becoming kind of like the center of HPC and also AI for Kubernetes. And Q is basically a job queuing operator. Its basic primitive is that it will pause all jobs in your cluster, and it will unpause one by one depending on the resource availability, right? So Q knows that Kubernetes is going to try to allocate all jobs at the same time because Kubernetes was designed for oversubscribing. So then Q goes and revise all the jobs that you have in your cluster, and one by one, it says like, okay, there are enough resources for you now. There are enough resources for you now. And it starts doing that one by one. And we have been adding HPC features to Q, right? It's a slim implementation, like it's very lightweight. It is not going to consume resources from your cluster, although it's recommended to run Q among other controllers in an infrastructure node and not in a worker node. And it uses all of the core API or APIs from Kubernetes, and we are building more APIs for Q, so Q and Kubernetes can communicate better. So roadmap, we're building budget support, meaning Q is going to do batch scheduling for you, also knowing about your credit card. It's going to have multi-cluster support. It was already merged a couple of months ago, and it is now like in an alpha state. And the idea is that you can have multiple Kubernetes clusters, and Q is basically going to try to deploy your job in all of the clusters to find the best cluster for your job. Or you can also configure it to deploy the job in all of the clusters at the same time. It goes with your use case, right? But the idea is that now we can have multiple Kubernetes clusters, and this comes handy for those that are purely cloud native, and maybe you have like a European cluster, a US cluster, an Asia cluster for serving your customers, and you want to run the same deployment in the 3 clusters, so Q can do that for you. It has flavors, cooperative preemption. So we are building things, the regular things that are in SLURM, like job preemption, checkpointing. We are building that into Q. So it's just a matter of time, 1 year, maybe 2 years, where Q is going to give enough tools to Kubernetes to compete one by one with SLURM. Now, GPU utilization. I wouldn't be NVIDIA if I don't talk about GPUs here. And I already said AI at least 100 times. So if I talk about GPUs, my work here is done. So how do you use GPUs in SLURM? You need to define a GRES, right? I think I'm pronouncing GRES from my Spanish accent and not from the English accent, but that's okay. For those SLURM savvy, this is the flags that you need to set for configuring a GPU in SLURM. SLURM, by default, when you deploy it in a cluster with GPUs, it will interact with the drivers, and it will expose that information to SLURM via a SLURMD or the SLURM CTL, right? And this is also have here. So this box here is how a SLURM savvy data scientist will require the type of GPUs that the person needs. Here we can see that the person is requiring MPS, meaning that they want to do a time splitting of the GPU because they only have one GPU and they want to optimize the usage of that GPU. But then how do we map this to cloud native? And this is kind of like the exciting part that we are working today for Kubernetes, and it's something that we are calling dynamic resource allocation. And here is where, as I was chatting over coffee, I feel like things are going to start growing faster for cloud native than in HPC. There are a lot of interested parties making sure that you can do fine-grained dynamic resource allocation over GPUs, not just for NVIDIA, but there are Intel engineers, AMD engineers sitting at the table designing this tool for Kubernetes, which in a couple of months, because this is already in alpha and it's getting into beta, in a couple of months, this is going to be much better than a GRES because it will give you fine-grained control on how do you allocate and how do you use resources when scheduling resources in Kubernetes. And how does this actually work, right? So maybe if I stand here. So basically, each provider, when I mean provider, each NVIDIA, Intel, AMD, Google with their TPUs. I recently read that Apple is going to launch themselves into the ecosystem and provide GPUs also. So each provider has a responsibility to write the array resource driver. Right? So it goes into the vendor to provide a driver that you can use. This driver is going to communicate with the kubelet. So for those that know Kubernetes, the kubelet is for SLURM, would be the SLURM daemon on each worker node. So the resource driver is going to communicate with the kubelet saying okay, you are sitting on top of a node that has this type of GPUs, and this is the feature set of the GPU, right? So not just the type of GPU, but you can do all of these nice things to this GPU, right? Partitioning, this is how much memory does this GPU have. This is how much that GPU utilization, right? So the kubelet knows that, okay, this GPU is half utilized, is not being utilized, is fully utilized. The kubelet is going to be aware of the resource, not call it GPU, anything, because we can also do resource drivers for network cards. So we can also open the door for better fast networking MPI in Kubernetes. So then the kubelet communicates that back via the API server to the Kubernetes scheduler. And then every time someone is requesting, okay, I want to launch a pod with a GPU from AMD, NVIDIA, Intel, you will have to put the name of the vendor, right? I want an NVIDIA GPU with this type of feature. You can be very, very fine-grained control. And with the new GPUs like a Grace Hopper and the more expensive ones like the Blackwell, that they are going to have this plethora of features, you can define which features do you want to use from the GPU. Then the Kubernetes scheduler is going to go and read kind of the inventory of nodes, and it's going to say, okay, I have 2 or 3 nodes that matches what the person is requesting. and then it's going to allocate the pod or the jobs to the nodes that have these features, right? And then it's going to be responsibility of the resource driver to take the container and allocate inside the container everything that the user was requesting, right? So if the user was requesting, okay, I want a GPU, but slice it using MPS or using MIG, and when I slice it, I only want this much of memory, and I only want this and these features from the GPU, but I don't want this and these features from the GPU, it's going to be responsibility of the resource driver to read the request from the user and configure the container with the features that were requested by the user, right? So we are getting into a fine-grained control of how we use resources in Kubernetes, and not just how we use it, but how we schedule them, because the scheduler is going to be aware of all the features that you have in your node. So this is kind of exciting. This was barely approved before KubeCon EU Paris a month ago. And the idea as a community is to approve the beta for the next release of Kubernetes. So we are working really hard to get this done. And as I said, all the vendors are sitting together in a table, which is really nice because we see Google TPUs, Intel, NVIDIA, like everyone working around defining these structures so users can better utilize these accelerators. Now, model evaluation and refinement. Here's where things get a bit funny and I start closing. And it's a growing landscape, right? As I said, it doesn't even fit a slide. I just try to shrink it down. So this is all the approved tools that already work in Kubernetes for many things. Training, just setting the parameters, a marketplace for tools, workflows, benchmarking of your models, feature engineering, operations. Like, this is the landscape, and it grows by the week. Like, each week there is a new tool added to this table, where you can just pick, like, okay, I want to do machine learning. This is how I'm going to handle my data. This is how I'm going to use my model. This is how I'm going to distribute it. You can just scan the QR code to get it bigger. And in a matter of a week, you can build a working cluster for training AI ML models in Kubernetes, right? Because there is an entire landscape of vendors from many companies that they are offering their tools to help you get your model trained faster. And the good thing is that all of this builds on top of the APIs that I just mentioned, right? Like Q, the dynamic resource allocation. So all of them uses the same APIs. So it's portable. Something that in a SLURM is not so portable, right? Like moving from a SLURM cluster to another SLURM cluster is not so easy. And for those that have moved universities, you know that in a university, a SLURM is working one way, and if you try to replicate your SLURM scripts in another university, you need to do adjustments. With Kubernetes, since it's the same API and all these frameworks are sharing the same APIs underneath, you can move from Google to Azure to Amazon to on-prem, and it's the same API, it's the same scripts. The only thing that you need to move is how many resources you have, of course, but the rest is the same API. And what's to be done? What's keeping me busy these days? We have created as a community what we call working groups. So you can, I forgot to create like the QR code, so it was easier for you, but these slides are going to be shared by HPC now. So there are three working group of interest for this meeting, and it is the working group BAF, working group serving, and the working group device management. These three working groups are trying to tackle the three main working streams of how do I train and serve a model in Kubernetes. So batch is mostly focused right now on training and distributed running, so MPI. Working group serving is going to be focused mostly on, okay, I have my model trained. Now, how do I do inferencing in Kubernetes, and how do I configure my model to be always running so users can consume it and I can make money out of it? And device management is a working group that is going to be mostly focused on all the new hardware features that are coming and how do we enable those features to Kubernetes. And the first kind of like a shining start from the device management is the DRA tool, right? So at this working group, you get to see vendors from all organizations discussing how to enable accelerators into Kubernetes. And with that, thank you.
Any question for the speaker?
Sorry, I'm always asking questions. If you were to bet on the future of HPC and AI, would you bet on the Kubernetes scheduling, or would you bet on the mixture of Kubernetes scheduling and SLURM-like schedulers?
I would bet, if you're saying the word future, I will fully bet on Kubernetes, because the mixture is the today, is not the future. Just today, as we saw from HPC now, there are many others like this CoreWeave company that they are running Kubernetes and SLURM side by side. But as time goes by, Kubernetes is building a community to build the things that they don't have today. So it's just a matter of time for Kubernetes to be a one-on-one mapping of SLURM for Gantt scheduling, for batch scheduling, for all the nice tools that SLURM presents. The community is building them. Right? If you go right now to the Kubernetes GitHub repo, there are open contributions to make this happen.
Sorry, if I pose the question slightly better, are you suggesting that the HPC community might adopt Kubernetes as a default way of its class? Yes. Okay.
Again, it's not a future. That's not a future question. There are multiple HPC, like old school HPC facilities already deploying Kubernetes at a large scale.
Sure. Sorry, again, I'm asking whether or not SLURM has a future.
It does, as everything open source. Like I would hate to see an open source project die, SLURM or any other, and I do think it has a future. I just think it's a matter of vision and building a community on like bringing SLURM to a bigger community. Myself, I created a pull request at this big landscape table proposing SLURM to become a cloud-native tool. Because if we all gather around SLURM as we are doing for all these other tools, SLURM could become a tool that you use from Kubernetes. If we get to do that, SLURM has a future. Because instead of wasting all the effort that we're doing to build some features in Kubernetes, we could just mold SLURM to be a tool of Kubernetes, right? So that's my vision of the future. I know there are many people that don't share that vision of the future, but I feel like if SLURM becomes just another tool of the cloud-native landscape, it has a future and a big future.
I will ask again the same question in the panel.
So thank you, Eduardo, for the talk. Today, sustainability is the topic, right? And in HPC community, we're very focused on performance, and performance and portability usually don't go together, right? Except if we talk about easy, but that's still...
and Vanessa's talk is also going to be about portability and compatibility.
Yeah, so one of the challenges that I see, especially on AI, right? AI is consuming a lot of power, right? Computing power, and we don't focus enough on optimizing the workloads, especially because, as you mentioned, this is focused on portability, right? So users have no clue what is the underlying architecture that they are going to run on. So how can Kubernetes expose this and make the optimization path easier for the users?
There is as I said, a working groups. There is a working group that I don't mention here because I'm like fully focused on HPC and getting things done. But like Kubernetes as a whole, there is a working group, sustainability, and they are creating APIs mostly for the cloud vendors where you can tag along with the Kubernetes autoscaler, and you can say like, okay, I want to do cloud bursting, but I want to do cloud bursting in CO2 positive clusters. And this mostly means like deploying Kubernetes in like Nordic clusters. That is kind of like what is happening. But there are some APIs that are being built into Kubernetes to request Kubernetes when it is auto-scaling to auto-scale in like green clusters. So they are building that. When I was at Red Hat some years ago, OpenShift is also building some metrics into this Prometheus Grafana tooling. So it is also going to expose your energy consumption, and you can configure OpenShift, and by doing that, Kubernetes to be like less power aggressive. So Kubernetes is also working there because, you know, cloud providers are very like not the cloud providers, the owners, but we, the engineers, we care a lot about the environment. So we, the engineers, are building tools into Kubernetes and into the cloud APIs, the SDKs, so you can request green clusters when you're auto-scaling.
Thank you. There's a comment around here. So it could be nice to know or to see how Kubernetes will run performance analysis tools, for example, for analyzing and allowing computational scientists to optimize code. I'm talking about something that can run on a single node, but on a multi-node, larger scale kind of MPI jobs in the way we usually do on a kind of a SLURM cluster, traditional HPC cluster, which is, I believe, what Carlos was asking for. And so following up this conversation that we had before, landscape is changing, and we are talking about a lot about AI, but it's not the only community demanding an easier platform to get started. So that's why we see a lot of interest around open on demand, which allows you to bridge the gap and getting things done really quickly without having to understand all the complexity about Linux and transferring data through SSH and getting started with a editor that it's command line interfaced and a few things like that. So at the end of the day, you need something that it's easy to work and easy to manage, and portability of your workflows, it's extremely important. So I think it's
an example that I don't see here, but it's from Barcelona, is Nextflow.
Yep, that's it.
Paolo Di Tommaso. Nextflow, that is a bioinformatics tool, not a AI hype tool. Nextflow supports Kubernetes. Yeah. And this kind of like has made Nextflow be a really nice tool for bioinformatics, because you can just use Kubernetes in the clouds and get your bioinformatics done. So yeah, that portability of Kubernetes, like one use case is Nextflow, like away from AI, and is proven to be really successful.
Okay, we can keep the discussion in the panel. So let's thank again Eduardo for his answer.